Okay, so this is our last set of notes. We're going to talk about the discriminant. So looking at the definition, the discriminant of a quadratic equation is a numerical value. So it's just a number. And it's a number that's going to reveal both the number and type of roots a quadratic equation has. What is a root? An x-intercept. So basically the discriminant is a number that's going to tell you how many x-intercepts we're going to have and what kind we're going to have. Whether they're like an integer, like the x-intercept is 5 and 2, or if it's going to be imaginary, where it has an I value in there. It's going to tell you what kind we have, okay? So if the discriminant is greater than 0, or if it's positive, we're going to have 2 roots, meaning we're going to have 2 x-intercepts. If it's positive, you're going to have 2 roots. Now, let's see what type of roots we're going to have. All right, so if we get the discriminant that's positive, we're going to get a rational if it's a perfect square, and irrational if it's not a perfect square. So a rational number, that's a number that's on the number line. Irrational, it's also on irrational, it goes on forever, like pi, 3.14, and it goes on forever. Or the square root of 2, it's just a whole bunch of numbers after the decimal, that's irrational. It goes on forever. Okay? If the discriminant is equal to 0, we're going to have 1 rational solution. And if it's negative, we're going to have 2 irrational solutions. It's actually going to be imaginary. Let me write the word imaginary. They're going to be imaginary, meaning it's going to have an I in it. And the formula is b squared minus 4ac. That is the formula for the discriminant. Now, that formula should look familiar because yesterday, the quadratic formula was x equals negative b plus or minus square root. We had the discriminant right here, b squared minus 4ac, all over 2a. This was the quadratic formula. So your discriminant is included in the quadratic formula. And when you think about it, this makes sense. If under the square root, the b squared minus 4ac, if I get something like 4, what's the square root of 4? 2. We're going to get some good numbers, right? It's going to be a rational number. It'll be easy to graph it. So if we get a positive number under the square root and it's perfect, like 4 or 16, 25, 81, where you automatically know what the square root is, you're going to get 2 rational numbers. You'll easily be able to graph it. Now, let's say I had a number like 42. Is that a perfect square root? It's still positive, so you're going to get 2 answers. However, it'll be irrational. You'll have something like, I'm just making this up, let's say 4 plus or minus the square root of 8 over 2. An answer like this is irrational, okay? Because we didn't have a perfect square root here. Make sense? All right. And then if it equals 0, you're going to have 1 rational one. So that means your graph would look something like this. You just have 1 x-intercept instead of 2, okay? And if it's less than 0, meaning it's negative, if your discriminant is negative, that means we're going to have a negative number under the square root. Whenever you have a negative number under the square root, that means you're going to have the letter I, right? So that's why we have 2 imaginary solutions. Okay, let's go ahead and move on. So let's find the discriminant. This is our formula, b squared minus 4ac. So let's go ahead and do number 1. Let's go ahead and label what a, b, and c is. A is 2, b is 12, c is negative 13. Then I was just plugging into my discriminant formula. I'll have b squared minus 4, a is 2, c is negative 13. And then we just evaluate it. So 12 squared is 144 minus, let's just evaluate what this value in my box is, okay? So we don't get confused with all the negatives and positives. So 4 times 2 is 8. 8 times negative 13. Can someone tell me what that is? Oh, perfect. Negative 104. So the value of these numbers being multiplied is negative 104. And then we're subtracting it. So these will just become plus signs. So that means my discriminant is 248 when you add them together. Okay? So looking back at our notes, that means we're going to have 2. Is this a perfect square root?
No.
No, it's not. So I'm going to have 2 irrational solutions. I'm going to have 2 irrational solutions. I'm not going to get pretty numbers. Okay, number 3, we're going to have to rearrange this before we start. I'm going to rewrite this as negative 4x squared minus 10x plus 84 equals 0.
Okay, so number 1, the answer is 248.
Yes, the discriminant is 248. And then when it says determine the number and type of roots, we'll have 2 roots and they will be irrational. Yes. Because going back to our chart here, if your discriminant is positive, you're going to have 2 roots. If it's a perfect square, it'll be rational. If it's not a perfect square, you'll get 2 irrational. So that's how we know we get 2 irrational solutions. All right, number 3. So number 3, I rewrote it. I just moved this 10x to this side, making it a minus 10x. And then you do the same process. Identify A, B, and C and find the discriminant. Okay, so I'm going to let you guys do the rest of these examples. I'm going to pause here. So guys, this whole unit, we have been learning different ways to find the x-intercepts. We found the x-intercepts by graphing, factoring, using square roots, completing the square. Yesterday, we did the quadratic formula. So we're going to talk about what's the best way to find your answer. There's multiple ways you can get there, but what's the most strategic way? So graphing. Graphing is great whenever you have simple numbers like 5 and negative 2. You can easily plot those points and find your solutions. So you can use graphing sometimes. Go ahead and write sometimes. Okay? And it's great when your roots or your x-intercepts are integers. Numbers without decimals. Okay? Factoring. This can be used sometimes. Because let's say, for example, let's say I gave you something like x squared plus 3x plus 4. Can you guys think of 2 numbers that'll multiply to give me 4 but add to 3? No. There's only 1 times 4, but those don't add to 3. Those add to 5. So factoring didn't work in this case. Okay? So this doesn't always work. So factoring is best when you have roots that are rationals. When your roots are rationals. All right. The square root. We can use this sometimes as well. And this works best whenever you do not have a b value. So when you do not have a b value or a b term, that works best. So for example, when we were doing square roots, we would have something like this. X squared minus 25 equals 100. Maybe something like that. Oh, I'm sorry, that's not what we had. We had something like this. Okay, we didn't have a b term. We just had a and c. So then we just took the square root of both sides and then we solved. Okay, so the square root one, that works best when you do not have a b term. Okay, completing the square. This will always work. However, it works best when your b term is even. And let me show you why. When we were completing the square, we would have something like x squared plus 16x plus 30. And the first step was to move the 30 to the other side. So we would have x squared plus 16x equals negative 30. And then what we did was we took half of the b term and then squared it, right? So guys, what is half of 16? 8. And then you squared it and got 64, right? Okay, so what if we didn't have an even number? What if we had like 15? Half of 15 is 7.5. So you want to get a nice number. So completing the square, it works best whenever your b value is even, okay? All right, quadratic formula, that will also always work. And that works, do the quadratic formula when all of these other methods fail. And you're like, I don't think I want to factor. Factoring won't work. Square root, I have a b term, so that won't work nicely. So whenever all else fails, you can always do the quadratic formula. That will always work. Okay? So what I'm going to have you guys do, I want you to discuss with your groups. I have 4 equations up here. I want you guys to first find the discriminant and tell me how many solutions each of these will give me. Then I want you guys to write the equations in each of these 4 boxes. So for example, equation A, that might best be solved using maybe the quadratic formula or completing the square. You have to decide which one should go in which box method, okay? One more thing that I want to remind you of, when we're completing the square, it works best when your a term is 1. Because let's go back to this example here. Let's pretend there was like a 3, or let's say there was like a 4 right here. Whenever you divide everything, because first you have to divide. Let's work this problem down here. It'll be 4x squared plus 16x equals negative 30. And then you would have to divide all of these by 4. So then I'll have x squared plus 4x equals, and this is an ugly fraction here. This will be negative, we can divide this by 15 and 2. So this will be negative 15 halves. When you simplify it, you can still do this. It'll just kind of be ugly because you have fractions, okay? So completing the square works best that your a term is 1, okay? And if it's not 1, maybe you want your a term to be easily divisible by both a, b, and c so that we won't get fractions, okay? So having that in mind, I want you guys to think about which equation out of these 4 would best work with completing the square, okay? I'm gonna pause here. Okay, so for factoring, out of those 4 equations, equation C works best for factoring. So we should put equation C up here, and we'll solve it using that method. For square roots, equation B was the best one to do for square roots. For completing the square, equation D was the best one to do completing the square with. And the reason why is this one has an even number for B. And the A value is 1. Because A is 1 and B is even, completing the square works best. Okay? Square root, this one works best for square root because it doesn't have a B. There is no B term. So that works best whenever you don't have a B term, you want to do the square root method. Okay? The reason why we're doing the quadratic formula for this one instead of factoring is because we could not think of two numbers that will multiply to 21, but combine to give you -9, right? Our numbers would be 1 and 21, 3 and 7. These don't add together to give you -9. So we couldn't do factoring. So we're just going to use square root for this. I don't want to do completing the square because this is odd. Okay? I wouldn't do square roots because this has a b term. Okay? So these are the different ones we should use. I'm going to pause here and let you guys solve, and then we're going to come back. Okay, so the first one, we're going to factor. What I would do, I'm going to do 3 times 7, which is 21. So I need two numbers that multiply to 21, but combine to give me -22. Can y'all tell me them?
-21 is -1.
Yes, -21 times -1 is 21. If you combine it, you'll get -22. So my factors will be x minus 21, x minus 1. This is the part that a lot of people forget though. We need to divide by the a value. We need to divide by the a value. So this will simplify to x minus 7. This fraction is already simplified, so now I'm just going to bring the the denominator to the front. So these are my factors. These are my factors. However, now we need to solve, okay? It wants us to solve. So what I'm going to do is I'm going to do x minus 7 equal to 0 and solve that equation. And then I'm going to do 3x minus 1 equals 0 and solve that equation. So when I solve, I'll get x is 7. And move that over here. So I'll get 3x equals 1. So you'll get x is 1/3 when you solve. So those are your two rational solutions. You can easily graph that. Also, if you did the previous part of finding the discriminant, what was the discriminant of this equation? 400 what? Oh, just 400, okay? So you can easily take the square root of 400. It's just 20. So we'll get good numbers. That's why we got good numbers here. Easy to graph. Okay, now we'll do the square root method. So I want to get x by itself. I'm solving for x. So we need to get x by itself. So I'm going to rewrite this as the 144 on the other side. Just move it to the other side. Get x by itself. Then I'm going to divide both sides by a -2. So now I have x squared equals a positive 72. Now that x squared is isolated, we can go ahead and square root both sides. So square root this side and it cancels out. Square root this side. So my answer will be x equals, I'll get a positive and negative answer. Let's simplify square root of 72. So 72, I can break this into 2 and 36. So that means the square root of 72 can be written as the square root of 2 times the square root of 36. Well, what's the square root of 36? 6. And then keep square root of 2 the same because that won't simplify. So my answer, I get two solutions, a positive one and a negative one, and this is irrational. The square root of 2, if you put it in the calculator, it'll give you a decimal that goes on forever. So we got two irrational solutions, yes? So a good question was asked. Someone said, can I use 8 and 9? I can. I can break this down to being 2 and 4. Because 2 times 4 is 8, times 9 is 72. So this can be written as the square root of 2 times the square root of 4 times the square root of 9. The square root of 4 is just 2. The square root of 9 is just 3. This doesn't simplify. So you get 6 square roots of 2. So you get the same answer. Good question. Okay, next, completing the square. So first, we need to write it like x squared plus 6x equals, move the -15 to the other side, making it a positive 15. Now we take half of the b value. What's half of 6? And then we square it, 9. So we'll have we'll add 9 to both sides. I'm gonna add a 9 here, and I'm gonna add a 9 here. All right, so now we're gonna go ahead and factor the left side. I need two numbers that will multiply to give me 9, but add to 6. 3 and 3, that's why it's a perfect square. We can write the factors as x plus 3 squared on this side. So that's a perfect square. And then 15 plus 9 is 24. From here, we're going to square root both sides. So I'm going to square root this side. That cancels out. I'll square root this side. Okay, I'm going to show my work off to the left over here. So I have x plus 3 equals the square root of 24. We can simplify the square root of 24 as, let's see, 4 and 6. What's the square root of 4? So this will be just 2 square root of 6. Okay, so my answer is x plus 3 equals plus or minus 2 square root of 6. And then just move this 3 to the other side, make it negative. So your answer is x equals negative 3, and then you have plus or minus 2 square root of 6. So we got two answers, and it's irrational. And then finally, the quadratic formula. So what was the discriminant when y'all did it? What's b squared minus 4ac? Negative 3. Okay, so that means my quadratic formula is x equals negative b, which will be 9, plus or minus the discriminant was negative 3, all over 2 times a, which is just 1. Okay, and then we'll simplify. What's the square root of negative 3? Yes, it'll be 9 plus or minus I square root of 3 divided by 2. So this is your answer. Our discriminant was negative. That's why we got two imaginary solutions. One answer is 9 plus I square root of 3 divided by 2. Your other one is 9 minus I square root of 3 divided by 2. You got two imaginary solutions. So you guys can predict how many solutions you'll have and what kind based off of the discriminant. When you did b squared minus 4ac here, you got negative 3. So I knew I would have an I in my answer. It would be imaginary. All right, I'm going to end it here.